All right, welcome everybody. This is our last lecture before the exam on Wednesday. So the homework assignment that you've got hanging over your head right now, homework number 7, that's due before class. And then we're going to have our exam starting at 12 o'clock. And I've already given you quite a bit of information about that. There are going to be both concept questions and problem-solving questions. The coverage of the exam is everything from the beginning of the semester up to and including today's class meeting. And we're not going to have any problems where you need to use Excel, not on exam 1. So then the only thing you need to bring is your calculator, a pencil, eraser. So any questions about the announcements? You can use any calculator as long as it's not on a cell phone. Other questions? Yeah.
How many questions is the exam going to be?
I haven't written it yet, so I'm not exactly sure. I mean, just speculating how many questions, probably between, including like the short answer type questions, maybe between 7 and 10. I'm mindful of the fact that you've only got 50 minutes to take the exam, and so I want to write it so that for people who know how to do the stuff, that time limitations aren't an issue. Of course, if you don't know how to do the problem, then you're going to feel pressed for time. But if you know how to do the problem, you're going to have plenty of time. Yeah.
Will it be like a good balance between conceptual and workout problems, or is like the workout problems?
I don't know. You'll have to tell me after the exam if you felt like it was a good balance. But what I think I said before was about 35% of the points will be related to concept questions, and about 65% of the points will be derived from problem solving. So I think you'll spend more of your time solving problems than answering short answer questions is my guess. All right, so the last thing we're going to be talking about today is annual worth analysis. And you've already done the annual worth method. So let me drill this at you one more time. What's the difference between a method and analysis? Anybody remember from our class on Friday? I'm hearing it in stereo. I'll go here. What is it?
I think you said you use the method to get the analysis.
Okay, good. You use the method to perform the analysis, and the analysis includes the decision criteria. The number one thing is that we're comparing among alternatives when we perform the analysis. So we're choosing which of these options is best by applying the method to both options, and then we utilize the decision criteria to tell us of the options which one is most advantageous. All right. So in annual worth analysis, what we do is we apply the annual worth method to compare among alternatives and choose whichever one is best. And there's some nice things about the annual worth analysis method. It solves some problems that we had before when we were doing present worth analysis or future worth analysis. So let's just visualize what happens during an annual worth method. What we do is we start off with a cash flow diagram that's irregular. In this illustration, what it seems to be showing is an initial purchase price for some equipment. And then here in year 1 is just an isolated future amount. That maybe would be associated with refurbishing the equipment or getting it set up for use. And in addition, there happen to be annual expenses, probably related to operation and maintenance, maybe fuel costs or labor costs. And then at the end of its useful life, there is just a solitary future value that's associated with a salvage. And so maybe you're retiring the item and just getting some scrap value out of it. So in an annual worth analysis, what we want to do is convert all of these sole, future, and present values so that it's just all expressed as an annual series. So the amounts that's already as an annual series can stay there. What we need to do is we can compare alternatives. Like if we have multiple options, normally we'd have to make them the same length, right? like using the LCM method or contract services or early termination, if we're comparing two alternatives that have a different length, we have to make them the same. The big advantage that we have with annual worth method is that you don't have to do that because it automatically assumes whenever you compare alternatives using annual worth method, it assumes that it could be repeated. And so you don't have to go to the trouble of figuring out what's the least common multiple of two options. So what you do have to identify is these stray solitary amounts that aren't yet annualized. And so here's one, the amount at the present. Here's another, the refurbishment cost and the salvage value. And so when you're applying the annual worth method, what you have to do is use the factors or the equations to take these amounts from where they are now and annualize them. Now, you only have to apply it, like I said before, for a single life cycle. So what that means is that if you have two options and you find the annual expense of both, you don't have to bother making them last the same number of years, because essentially what you're doing when you're annualizing them is you're taking the purchase price, the salvage value, the operation and maintenance, you're doing all of those things and you're just figuring out how much would it cost each year. And sometimes this is a really convenient thing for businesses rather than a big software expense all at once to purchase like a program. They'll pay a recurring fee for it instead. I think that one notable example of that in recent years is like the Adobe Creative Suite, where in the past Photoshop and Adobe Illustrator and some of the video editors used to just pay like thousands of dollars up front and then you owned the software forever. But what they've done instead is they've moved to a model where you pay a monthly fee and then you have unlimited access to their software as long as you continue to pay the monthly fee. And so that paying monthly rather than all at once is easier for a lot of people. T-Mobile started doing the same thing with cell phones, where they, instead of having the carrier subsidize it or having you pay all up front, they just kind of finance the phone for you and then you include a certain percentage, like $15 a month of your bill would be to cover the cost of the equipment. And so annualizing the expenses of things is easier for businesses because revenue usually comes in on a periodic basis rather than all at once. So in the analysis, we can compare the things without having to manually adjust their useful lives. And so the assumptions, though, when you use the annual worth analysis, is you're assuming that you're actually going to be using the item for at least the LCM. So you're not going to be terminating any of the options early. And so if there's a piece of equipment that lasts for 5 years and you're comparing it to another one that lasts for 8, you're assuming that in the case of both options, you'd use those items for at least the least common multiple. And so it's assumed that you're going to repeat the cycle. So the selective alternative will be repeated if you're comparing two options. And again, because of that repeatability, then you assume that the repurchase price and the revenues and the costs of maintenance, all of that would be the same in each life cycle. There's a very specialized application of annualizing costs, and that is when an item lasts for an infinite number of years. So there are some big pieces of infrastructure that with enough maintenance and refurbishment are anticipated to really never wear out. Like when a dam is constructed, it's possible that the dam could be in place for tens of thousands of years, which is effectively an infinite life when financial calculations are assumed. Think of other things that have been around for a really long time, like the Golden Gate Bridge in San Francisco. Maybe you've already heard that they paint that thing continuously. They start at one end and they start painting, and by the time they get to the other end of the bridge, it's time to start again at the front side and start painting and refurbishing it again. So some things will last forever, and the capitalized cost of something that lasts forever is actually pretty simple to calculate. If you want to know the present value of some annual series that lasts forever, all you have to do is divide the annual amount by the interest rate that applies. So what this is showing, if you look at the direction of the cash flow diagram, this is saying there's some investment that will pay a return forever. And so if there was an investment that paid a return of $50,000 during each period for an infinite number of periods, then you can find out the present value of that, how much you'd be willing to pay for that investment by just dividing the 50,000 by whatever interest rate applies. A, in this case, represents the interest on a perpetual investment, one that never ends. And so we've talked about like dams and bridges. We can also just make it a purely financial instrument, like a deposit into a checking or savings account. So if you wanted to have an annuity, which is a type of financial structure that pays its owner every month for as long as they're alive, people will put a lump sum into an account and then get a guarantee to receive monthly income for the rest of their life, and that's called an annuity. Somebody at the financial company is trying to figure out not only what are they going to be able to earn on the deposit they take from you, but they're also calculating your probable life because they're on the hook to pay the annuity until you die. So it's someone who's like in the insurance business would have a pretty good understanding based on your health and your age and that sort of thing, demographics. So they're trying to figure out what would be the cost for a certain amount of guaranteed for income forever. It's the same approach. So just as an illustration using these numbers, if you wanted to put a certain amount into account so that you could withdraw $50,000 each year for the rest of your life, and that account pays 10% interest, then calculating how much you have to deposit is simply as easy as it's the $50,000 that you would withdraw each period divided by 0.10, and so then the present value you have to deposit will be $500,000. Of course that makes sense. If you put $500,000 into an account and it pays 10% per year, rather than reinvesting the interest so that it can compound, what you're doing is you're taking the interest out each time it gets paid. And so you're living on that interest, and so the balance never increases. And so the balance each year stays at $500,000. It's just that the 10% the bank is paying is on that original deposit amount of $500,000, and you keep taking out the interest. And so then that's a perpetual investment. Now over time, the $50,000 per year that you're withdrawing, it's continually becoming less and less valuable. So maybe the first year it would be pretty easy to live on $50,000, but then 20 years into the future, when there's been lots of price inflation, it's going to become increasingly difficult if the fixed amount stays the same. So here's the Brooklyn Bridge, and a lot of these public sector projects have really long lives. And once you get over about 50 or 70 years, then the effect of time becomes so small, because if you're discounting amounts from 100 or 200 years in the future, their present value is almost negligible. So in situations like this where it is a cost alternative and it's not necessarily going to be generating revenue, like in the case of a lot of bridges, there are some toll bridges, but most bridges don't charge a toll to drive over it. It's just we assume that the public is getting benefit of out of that infrastructure being in place. So to rearrange the equation I showed you on the last slide, if you know what the original cost was, and you want to find out the annual equivalent for an infinite number of years, then all you have to do is multiply the present cost by whatever interest rate applies. And capital recovery, this phrase capital recovery, is something that we'll look at a couple more times today. What it means is it's the amount of revenue or benefit you have to get from a project to justify its original investment. So in this case, in the illustration of a bridge, if a bridge costs $100 million to build, So if P was $100 million, and you assume that the municipality that borrowed the money has a certain interest rate that they're borrowing the money at, then what you can do is you can calculate the annual amount of benefit that has to be generated by that bridge in order to justify the original expense. And since it lasts infinitely, there's no salvage value. It just stays in place forever. Capital recovery more generally, in most cases, capital recovery does include a salvage value. But here, there isn't because the item lasts forever. Okay, so I think there may be a homework problem or two where you have to use this formula to convert between an infinitely long life item. So P equals A divided by I, or rearranging that algebraically, the A, meaning the annual uniform series, is the present cost times the interest rate. Any questions about that idea? Okay, now more generally, capital recovery is going to be the situation where you buy an item, it has a certain useful life that's defined by how quickly it wears out or how often you want to replace it. And at the end of that useful life, it has a salvage value. So that might be a vehicle of some sort, where you buy it and then you get rid of it at the end. Capital recovery is the annual value that balances these two things. So a capital recovery amount, what that means is that you're taking the present capital cost and you're turning it into an annual series over the useful life. And then whatever salvage value there is, you're also converting that to an A. And the capital recovery is the net difference between the two. So it only accounts for how expensive it is to initially purchase the item versus the salvage value. And you can think of it as, if you're going to be buying this for a business, you'd need to get at least this much revenue to cover the cost of the equipment. And if you can't get that much revenue, then the equipment isn't justified. Here's the formula that your book shows for how to calculate the capital recovery. Now, if we look at the cash flow diagram, and I tell you we need to annualize a P and an F, then you maybe are already thinking in terms of the factors. So here's that factor formula. It says that if we've got a P and then the salvage value, which remember was in the future, so the salvage value is an F, you'd multiply the present amount by an A/P. So that means find A given P at some interest rate for N years. Okay, so that tells you the amount of revenue you'd have to get to cover the cost of the initial purchase, and then the opposite sign of the salvage. So whereas the P was a minus sign because that's an expense, then the salvage is a revenue, and so that's a plus sign there, but we're doing the A/F because the salvage was some years in the future, and we'll utilize the same interest rate and the same number of years for each. One thing I'll point out is in the case of an A/F, the F is in the same year as the last A. That's the standard convention for an A/F, whereas the P, the present value, is 1 year prior to the first time you see the annual amount. In the case of a future value, the future value is in the same year as the last annual amount that you have. So just as it's shown here, that's the kind of the accepted notation for find A given F. So this is the capital recovery formula. And so this is a concept you need to understand. Remember, on the exam, you're going to be facing some short answer type questions. So capital recovery is the equivalent annual amount that an asset, process, or system must earn each year to just recover the first cost and a stated rate of return over its expected life. And salvage value is also considered. Okay, Now I want to give you a hint on a certain one of the problems that's coming up on the assignment. Has somebody already looked at problem 611? You've already taken a crack at it. This one's pretty complicated, and I wanted to help you just understand how to interpret this lengthy problem. Okay, so what it says is a certain person is getting $500,000 and they're going to purchase a condo. She hopes to make 8%, ownership period of 20 years. Now here's where we start applying the stuff we've talked about today. The condo's first cost is $500,000 and she expects to sell it for 90% of the purchase price. So what you should already be thinking about in terms of like a cash flow diagram is, what does this diagram look like? An expense at year 0 of $500,000, a salvage value in year 20 of $450,000, and that's an arrow upward because it's 90% of the original purchase price. And we're not including maintenance and operation in capital recovery. Capital recovery only includes the first cost and the salvage value. So this problem, the Hawaii thing, $500,000, $450,000. She wants to make 8%. So you're calculating the annual series of that. Okay, so you can go to the table or you can use the equations, and essentially part A is you're just finding A where you've got both a P value and the future value that's 90% of P. Okay, now part B gets a little bit more complicated. Once you've already finished part A, in part B it says if there's a boom in rental real estate 10 years in the future, what sales price is necessary to realize the same amount as the 8% return expected over the 20-year ownership period? Okay, so what that means is use the same capital recovery that you calculated in part A. So in other words, she buys the condo for $500,000. Then she receives income each year in the amount of whatever capital recovery you calculated in part A. And then how much should the condo be sold for in year 10 if I equals 8% for everything to balance out? So rather than it being the fixed $450,000 that it said in part A, what if she wants to sell it after 10 years? So what you're calculating is the sales price amount. So the advice I give you on this is draw the cash flow diagram because it really helps to summarize a lengthy word problem in a graphic that's a lot easier to understand, like what steps to start taking for the calculations. Just to jump from this much text to the table lookup factors is a lot harder than if you translate it first to the cash flow diagram and then you'll start to visualize the solution strategy a lot easier. Yeah?
For part B, would you consider the capital recovery amount past year 10?
No. No. Yep. Since she's selling the item in year 10, she wouldn't be entitled to the revenue from any years after that. Okay, so I have an in-class exercise for you today, 2 problems, one on the front, one on the back, just to get some extra practice with the annual worth method. It's been a while since you did the annual worth method. So what I'm asking you to do on this one is first think in terms of a solution strategy. So part A, what I'm saying is before you start actually doing the calculations, maybe write a pseudocode or like an outline of what order are you going to do. Maybe first you're going to take care of one thing, then you're going to move another thing from year 1 to 0, etc. So first do the solution strategy, and then what we're trying to calculate here is the equivalent annual amount if the whole thing is converted into an annual amount. And then on the back side of the paper, the question has to do with capital recovery. All right, since I know that some of you have already finished, I want to show you the solution on the screen here. And if you got both of the problems correct, then that's all I have for you today, and you're free to leave. If you're still not sure about a certain thing or you're working on it, I'm going to stick around until the end of our class time. You know, we've still got another 10 minutes. But let's take a look at the first one. So I suggested that you start with like a solution strategy, just kind of outlining what steps you're going to follow. So I identified these three amounts that aren't yet annualized. A should be spread out over, I called this A, meaning just like a certain amount. So the amount that's in the present, you use the A/P. This amount in year one has to be taken to the present before it's spread out over the annual series. And then this single amount, if you want, you can move it to the present and then from the present over an annual series, but that is more steps than you absolutely have to do. You could take care of it with an A/F because it's already in the form that is needed for an A/F. So in the end, what you ought to have is about 3.05 million, and it is going to be an outflow because we had more cost than revenue in that one. And you know, how many digits of accuracy do we have? Only 4. So what I would round it off to is 3,050,000. I guess the rest of those significant figures wouldn't apply. So maybe that would round up to 1. So that's the first one. And then the second, this honey wagon. All right, so I suggested a cash flow diagram as a good way to start. So we've got a present cost of $85,000, a future revenue when we sell the item, $18,500. And so what capital recovery means is on an annual basis, you're in the hole before you even start the year. Just to have the equipment, you're in the hole $15,865. And so that's how much revenue you have to make each year to cover the cost of ownership of the equipment. So that's kind of the definition of capital recovery, is on an annual basis when you balance out the cost of obtaining it and the cost of selling it, the annual equivalent. All right, so if you got that and you feel good about this stuff, that's all for today. Otherwise, feel free to stick around, and if you need to copy down what I've got on the screen, or if you've got questions, just let me know, and I'll be here to address them.